Hello and welcome to this video clip going through an alcohol's oxidation practical techniques leveled question. So we'll start by having a look at how you might want to answer a leveled response question. The key things to do are to read the question, looking for all the separate directions on what to do. Before you start, plan your answer out, so have a few ideas to pop down at the side so you can think about what you're going to do. What this avoids doing is waffling or repeating yourself. Problem with just jumping straight in and writing an answer is things might occur to you as you're halfway through that may need to be ordered and put in a logical sequence. So the plan will allow you to think about the sequence and what you're going to say in what order. So then you follow your plan to structure your answer and to check all the time that you're not missing anything out. Before finally checking your answer, reading it back to yourself, and then cross-referencing it against all the instructions and making sure they've been followed. So this one asks you to describe the oxidation reactions of butan-1-ol to form an aldehyde and a carboxylic acid. So that part is the chemistry topic area, is obviously oxidation of alcohols. Then the second sentence tells you what to do. So it says, explain using a diagram how the aldehyde can be produced in a laboratory by controlling the reaction conditions. So just to sum up there, we've got to describe the oxidation reactions of butan-1-ol, including the formation of an aldehyde and a carboxylic acid. So if we start by doing that in our plan, put the two parts of the question down separately, and our oxidation to form an aldehyde can be our first equation, and our oxidation to form a carboxylic acid can be our second equation. And in brackets I've just popped in there the reaction conditions and also the oxidizing agent. The synthesis of the aldehyde has to be done as a diagram because it says specifically that's what you've got to do. So now we can start following our plan using the two subsections that we then thought about. So the oxidation reaction can simply be just put in, stating what O is, then we put O in square brackets. The distillation reaction and the reflux reaction can both be put in. So we've included the formation of an aldehyde and we've included the formation of a carboxylic acid. So synthesizing the aldehyde, we obviously need to set up our reaction vessel. That's a pear-shaped flask. Put in the condenser and then add at the end the collection apparatus. Now we can start labeling it up. Our reaction mixture obviously being our butan-1-ol and the oxidizing agent. We've stated what that is already further up the page, so you don't need to say it again. We state that we've got a pear-shaped flask. Obviously the little blue arrow at the bottom is the heat, and the thermometer, still head and receiver, can be labelled as well. And it's important to say which end the water comes in so that you understand how to set this up, or you can show the person checking your answer that you understand how to set this up. So the H2O goes in on the right hand side and comes out on the left hand side, not forgetting of course to label our condenser. And finally we can label the distillate at the end. So just to have a quick check back over what we had to do, have we described the oxidation reaction of butan-1-ol? Yes. Have we formed an aldehyde? Yes. Have we formed a carboxylic acid? Yes. Have we used a diagram? Well, absolutely. How can the aldehyde be produced in the laboratory by controlling the reaction conditions? Well, that would be the use of the distillation apparatus as opposed to refluxing apparatus. So yes, that's covered as well. Okay, so hopefully this has been a reasonably useful brief roundup of how to approach this type of leveled response question as applied to an organic synthesis setting like this. Thanks for listening. Until next time, see you soon.